So hello guys, our next topic is epicycloid. Okay, so as you can see from this definition here, this is the definition what they've given, that an epicycloid, okay, is a curve traced by a point on the circumference of a circle which rolls along another circle, okay, outside of it and without slipping. So what is happening is that, as you can see from here, so it's a definition. So let's take a one circle here. Okay, so I'm taking one circle, bigger circle. Okay. So on this bigger circle, again, one small circle is uh, rolling above it. Okay. So let's change the color. It's far better. But it's fine, leave it. Okay. So here, as you can see, so what is happening is that here, you can see from here, this is my generating circle. Okay. This is my generating circle. Okay. Which is rolling on this bigger circle. Okay. So what is happening is that, let's take a point here. So I'm changing the color and making it into somewhat blue color. So let's take a point here, which is my point P. So when this circle, there is my smaller circle, is moving, suppose it's moving from this side to this side. Again, this is rolling over the bigger circle. It's going on. Okay. So when it's rolling, so it is forming some locus of points. Okay. And sometimes it is here, sometimes it is here, sometimes it is here. This it is forming a series of some locus of points. And when I'm joining all these points, okay, I'm getting a curve. This curve is called my epicycloid. This curve is known as my epicycloid. Okay. So if you see the pictures in your notebook or in your books given to you, you will just see this kind of figure, this much only. Okay, some angle will be here. So only this much part will be shown to you. This remaining part will be removed, or we can say it will be deleted. Okay. So again, I'm saying you epicycloid, okay, as you can see here, is a curve traced by a point on the circumference of a circle which rolls along another circle. Now, how to solve it? Okay. So first way to find is theta value. So theta is nothing but small d by capital D into 360 degree. So here small d is your 50 and this bigger one is 180 into 360. So this is 2 times 100 degree. So the angle what we are getting here is nothing but equal to 100 degree. Okay. Now next, like how to solve this question in AutoCAD. So I know from here that I am having one bigger circle. Okay. So if you see my figure in this part, this is the radius of the bigger circle. Okay. Which is nothing but equal to how much? 90 mm is nothing but what? 180 divided by 2 equal to 90 mm. But this from here to here is nothing but full circle of the full diameter of the smaller circle, which is nothing but equal to what? 50 mm. Okay. So this is 50. From here to here is 50. And from here to here is total 90 mm. Okay. So what I'm doing is that first I will draw one straight line. Okay. And before going that, as we know, my theta is equal to how much? 100 degree. Okay. Suppose I have drawn one this kind of figure. This is my 100 degree. So as I know, I will get one curve like this way. This is the epicycloid. Okay. So what I'm doing is that I will divide this angle into two parts. That means I'm drawing a straight line. So when I'm bisecting it, this become my 50 degree. Okay. Now from this, as this total is my 90 degree. So as this is 50. So this is how much? 90 minus 50 equal to how much? 40 degree. That means if I have drawn a line, okay, at an angle of 40 degree from here, two lines, one line, this one, this length should be of how much? 90. Okay. And another line, one more I have drawn. Okay. This other line is of how much? You see the top figure? 90 plus 50. Okay. Is equal to how much? Is equal to 140 mm. Okay. So this way, it will be easy for us to draw the figure. Okay. Now let's move to the software and we'll try to solve the question in the AutoCAD. And then we will try to do the other things like normal and tangent. So now you can see one question is that of an epicycloid. The draw an epicycloid of a circle of diameter 50 mm, as you can see from here. So diameter of 50 mm. Okay. And which rolls outside a circle of diameter 180 mm. Okay. So as you can see here two things they have given to us. Okay, one is my generating circle and one is a bigger circle on which is rotating. Okay. So first we will draw, as if you recall from here, that first we'll draw two lines at an angle of 40 degree, one at 140 mm at angle of 40 degree, another line at as 90 mm, then angle of 40 degree. Okay. So just take from here, and I'm just taking a line of first 90 mm, tab button to switch between the two boxes. Okay. And angle should be 40 degree. Enter. Again, to repeat the same command, press space bar or enter button. Again, other line is 90 plus 50 is 140 length. And again, angle is 40 degree. Enter. So as you can see here, you are getting two lines. One this line and another this one more line is here, which is overlapping it. Okay. So to check, you can see there you'll get a two end point here. One end point is here, which is represented by box. You can see here, and one end point is here. Now what I will do is that I will try to mirror the line. So from here, I will draw a straight line. So make sure that all your auto is on. Just draw a random line. Okay. And then select it, all the lines. Okay. And go for a mirror option. Now it is asking me specify the point of mirror line. So click on this part and this part. And here is the source object. No. So you can see here, you got point here. The line again you got here. Okay. So one thing you can see here, let me draw. Next 90 tab 40. Okay. Okay. So first draw the bigger line and then draw the smaller one. Okay. So now I'm going to mirror it again. No. Now I hope it's done. Yeah, there are two separate lines. As you can see, one this is a smaller one. Here also is a smaller one, and this is the bigger one. Now there is this extra line. So now check the angle. Always before going to the figure, okay, always try to check the angle. Always it's coming 100 degrees. So everything is fine. Now, just I have to draw one circle here, as I've shown in the figure that one circle is here. Okay. Similarly, I know the circle radius diameter is 50. So just will go for this 2-point option, 2-point circle. So I know one endpoint is here, which is my box, it is showing here. And another one is this. Can you see it here? By default, it is taking 50 mm. Why? So if you recall, 140 mm minus 90, I will get equal to how much? 50 mm. So I got 50 here. Similarly, to repeat the same command, just go here, click, and I got this point. So my two circles are completed. Now, again, the same thing what we have followed in cycloid, I have to divide a circle into some equal number of parts. Okay. So click here and I will draw one straight line up to this point. Okay. And then I will mirror this line. Sorry, I will go for the polar array command and I will break this circle into some 6 equal parts. Okay. And press enter. Similarly, I have to do it here also. That's why we should go for the, after doing all this thing, go for the mirror command. So that everything will come here. Or at least do it here and then mirror all the things so that it will come here. Okay. So no issue. I will do it again here. Okay. Again, select it. Go for the polar array. Go for the center. And as you can see, you have got all the 6 parts. Now again, we have to go for the naming. So I will go for this 1, 2, 3, 4, 5, 6, same like the cycloid. Okay. So before going to that, okay, first I will try to draw the curves here. Okay. So to draw the curve, always remember in AutoCAD software, the curve is always taken from in anti-clockwise direction, in counterclockwise direction. We cannot take curve in this direction. That is, we cannot take curve in this direction. Never. It will never happen. AutoCAD will always take the arcs, okay, arc always in anti-clockwise direction, CCW, counterclockwise direction, always. Okay. So I'll just show you how it's happening. Suppose for the drawing the arc, click on this arc option, go for start, center, end. Now, suppose I want to I want to draw the arc in this direction, clockwise. I want to show you. So this is my starting of the arc. Start, center, this is my center, and this is my end. So see, when I'm going with this option, the arc is coming in opposite direction. Okay. So I hope I made it clear. So in AutoCAD software, anything which is an angle will be always taken in counterclockwise direction. Now, to solve this one again, simply go to here, start, center, end. So in place of going from this direction, I'll go from this direction. Start, center, and end. I hope you got it, how I did it. Start, this is my start place. This is the center of the arc, and this is the end. Okay. Now when this is done, now again, I should not follow the same command always to move from each and every point. Okay. So to skip that point, simply I will go for the offset option. So click on this part, this arc. Okay. As you can see, this option is there, offset. Click on this offset. And this option, can you see here? Through. Click in this through option and bring up till here to the endpoint. Or better, you bring up to this endpoint. Okay, zoom it. Okay. Again, if you want to move it, again click from here to this endpoint. Again from here to the top endpoint. But we also want the center line, so bring up till this center line. Okay, I hope it's clear. And then press enter. Now this line should pass from this point also. So simply click here. Okay. And simply you can go for the extend command or simply lengthen it, extend. Okay, extend and select this part. So you can see here it's getting selected. Just click and it will just extend the lines. Now, as this is my 1 point, 2 point, 3 point. So again, I will go for the annotations. So I will take the values from here. So this is my 1. Okay. So I'll make a copy from here to this is my 2, I guess. So I'll make this object a snap of 2, 3, 4, 5, and 6. Okay. So I will just name it. This is my 1. This is my 2. This is my 3. This is my 4. This is my 5. And this is my 6. Okay. Now, as we know, this is my center line. So I will just change the color. Okay. And now, after I will even change the properties of the center line. Okay. Because there's a different way of representing center line. Now, again, as the same rule as I mentioned, as they divided the circle into 6 equal parts, similarly, I will divide this line also into 6 equal parts. So I will go for this div command, enter, press it. And how many parts? 6 parts. You got the points. Now, simply I will draw from each point. So again, I just click the object snap option. From here, I will join each and every point. Okay. Okay. Now I will name all the points. That is my C1, C2, C3 here. So again, I will copy the annotations from here. Okay. So this should be C, as we know, as the center. And then I will copy it from here to C1, C2, C3, C4, C5. Okay. It's my C6. Okay. As usual. So you know why it came close to this point? Because my object snap was on. Okay. So if you make it off, it will not come to that particular point. To this part. So this is my C1. Normally this one should be small. One should be small. It's a subscript. So how to make subscript? Suppose this is your C1. Double click on it. Select, click, and then drag your mouse. Okay. This one has become in blue color. It has got selected. Can you see here this option? That is called my subscript. If you click on this part, it will become C1. Okay. Similarly, you have to do for each and every part. Okay. So that you can do in your homework. It should be subscript. Okay. Now that is done. Now same thing like how we were following for the cycloid. We are moving this circle from this C center to C1, C2, C3, C4, C5, and then we were marking the points. Okay. So this common arc is this arc is a common for point 1 and 5. This is common arc for point 2 and 4, and this is common arc for just point 3. Okay. Similarly, this is common arc for point 6. Okay. So by default, we know that our point we starting from here. So simply to not to get confused, one point I'm marking it here. at this position. Okay, so again, switch on the object snap. One point is here, and one point is here by default because the point is starting from here. Okay, and I will get one curve. Now I have to move this circle from here to here, C1. So first I will draw one circle. So take center radius, and from here 25. We know that the diameter is 50 or 25 is the radius. I have drawn one circle. Now this circle, when it is at position C1, this circle is cutting this because as it is in position C1, okay. So as it is in position C1, we have to see the arc which is of which is passing through point 1. So this is the arc which is passing through point 1, okay. And this circle is cutting this arc at which position? At this position, okay. So while going, you have to see the left side of the circle. While coming down, you have to see the right side of the circle. Same like cycloid, same like the cycloid, okay. You can see this circle is cutting this one at this particular point. So I'll mark the point PO. I got one point here. Now move this circle. So click on the center and move from C1 to C2. Now this, when it's coming to C2, this circle is cutting this second arc at this point. So again, mark it P1, PO here. Again, move from C2 to C3. Okay. Now this circle is touching this last arc, which is passing through point 3 at this point. Again, from C3 to C4. Okay. Again, this arc is passing from 4. As we can see, 4 and 2 are having the common line. So while coming down, you have to see the right hand side of the circle. So this is the point 41. Okay. Again, click it and move to C5. This is 0.5. And by default, this is my last point. After that, you delete this circle. Now try to join it. Okay. So again, go to spline fit, the first option, and make your phase off and start moving. Okay. And tendency and press enter. Okay. I hope you got the curve here. So to make it thicker, just select the curve, make it 0.6. Okay, that's the curve here. So a curve is, your epicycloid is completed. Now it is saying, now what is saying? So draw a tangent and normal to the epicycloid at a point 135 mm from the center of the directing circle. Okay. Now when it's coming to cycloid, if you can see from here, I have taken a linear dimension because it was a straight line. Okay, so I can take the distance at a linear leap from the center, from the straight line. Okay, from this baseline, as it was straight. Okay, I was taking a linear distance of 35 mm. But as you can see here, when it's coming to epicycle, it's a curve. So I cannot go with the linear option. So I will go with the angular option. Okay, so what is saying? Draw a tangent normal at a distance of 135 mm from the center. Okay, so simply I will go to this circle, center radius, and from here, I will draw one circle of how much distance of radius? 135 mm. So you can see this arc is cutting this circle, this epicycloid at two positions, one here and one here. So to make it more visible, I'm changing the color. You can see the circle which I have drawn is cutting this curve at two positions, one here and one here. So again, it's up to your wish which one you want to take. I'm taking it here. So just I'm marking PO for point and marking it here. So I'll change the color to some different color. Okay. And again, I'm taking the font from here. So this is my point P. Okay. Now again, same rule from P, you have to draw a circle of this generating circle radius. So as we know, the question is of diameter 50, so radius will be 25. So from here, sorry, so I did some mistake. The P should be here. Okay. So from here, radius should be 25. So I'm making it 25. We can see this generating circle is cutting this center line at this point. Okay. So I got this point here, PO. I'm marking it. And this is nothing but my X point. If you see, just like cycloid, we are putting the same type, just like cycloid. Okay. So this is my X. Now, after finding the X value, from X you draw the line to join the center O. Okay. Sorry, I didn't mark here. This is my center O. This is my center O. Okay. Now, don't draw from here, from this O2 to this point P and extend it as a normal. Okay, it is wrong. So when I'm drawing this straight line from X to join to center O, this straight line, okay, or we can say this line is cutting this base arc at this point. Okay, so this point is nothing but your N dash. So this point, okay, this point is your N dash, this point. Okay, this point is your N dash. Now from N dash, you join to P, okay, and extend the line. This will be your what? This will be your normal. Sorry. Okay. And again on this normal, as if you draw the tangent, so we know how to draw L, enter, P, E, R, enter. And then we have to move the cursor on the line on which you want to draw a tangent. So I'm just moving on. It is showing a box or square shape. So just pull in whichever direction you want to pull. Okay. But this line should pass from this point P. So click on this line and go for this move option and take the midpoint. So traverse the cursor on the line. It will show a triangle. Click it and bring close to point P. Okay. So this is your tangent. Okay. And this is your normal. So I'm giving some thickness to it. Okay. I hope it's clear to you all. Okay. Like how to the normal tangent. This whole trimming part is all thing I'm not doing it. You can do by yourself. Suppose you just want to show it as a curve or arc. Sorry. Simply go for TR, two-time enter. And as I want to show this arc, click here and click this part. And then press K button and then grade the remaining circle. So it will look like an arc. Okay. So I hope it's clear to you all. And that's it for today. Okay. Thank you.